So here we're going to talk about the degree again, which we've discussed as the largest exponent of a single term. We mentioned if there were multiple variables in a single term that to find the degree we add the exponents together. That's what's going to show up in this section quite a bit. So when there's multiple variables, then the degree is found by adding the exponents together. So all of these problems are monomials. They're a single term, but they're made up of numbers and multiple variables, at least some of them. So this first term has an x squared and has a y to the third. So the degree of this problem is going to be 5 because we are going to take the exponent of 2 and add together the exponent of 3. So the degree of this polynomial is 5. The classification, which is what this column should really say, we're going to classify by degree of the polynomial. Degree 5 is a quintic. The second example, and again, it's only the exponents for the variables. So that's an x to the first power, y to the fifth, and z to the third. So we just add those 3 exponents together. So that is degree 9, the classification. I had to double check, but it is a nonic. This next one you definitely should know. X to the first, y to the first. So 1 plus 1, this is degree 2. Degree 2, you definitely need to know, is a quadratic. The next one is just a straight up degree 2, because there's only one variable in that problem. So there's nothing to add. The next one is a degree 0, because there's no variables. So that is a constant function. And then the last one, the degree 1, that is linear. Because again, if there's no exponent, there's an assumed exponent of 1 there. So here's just some extra practice with polynomials that have multiple variables in the terms. So let's do a couple together, and you'll have a couple to do on your own. So example 1, we're combining like terms. You'll notice there's no parentheses. So what you see is what you get, plus sign versus minus sign. When you add and subtract, remember the variables and the exponents have to be exactly the same. So my first term, let's go ahead and circle it, is a 9x to the third y. You got to look and see if there's any other exact x to the third y's in the problem. I see one other. And here we just add the coefficients. 9 plus 8 is 17, and you keep the x to the third y. That only changes when you multiply or, of course, divide. And then both of these are also like terms because both of these are xy squareds. If one of them was x squared y squared, then they would not be like terms. But now we're just going to add the negative 5 and the negative 12 together, and that gives us negative 17. And again, we're going to keep the xy squared. The degree for this problem is 4. Because again, we look for the highest exponent or the highest sum of exponents. So that first term has a sum of 4, and the second term has a sum of 3. So this is a degree 4, which means it is a quartic. They also want us to classify by number of terms. There's only 2 terms in this problem. Remember, this is a term and this is a term. So if there's 2 terms, that is a binomial. All right, in this final one, we are subtracting. There are parentheses, so there's a little bit of work to do. So remember, this means we are subtracting everything in that second parenthesis from the first parenthesis. So I would encourage you to distribute the negative 1 to that second parenthesis first. And what that does is it's just going to make the sign of the original problem, all of those signs opposite. So that positive 7y to the fifth is now a negative 7y to the fifth. The positive 2xy is a negative 2xy. The negative 12yx squared is a positive 12yx squared, and the negative 12 is a positive 12. And now we just need to find like terms. So I'm just going to start the end of the line, or the very beginning. There's a positive 5, and there's a positive 12. I'm going to add those together. I'm going to put the answer way over here, because remember, in standard form, the constant term is always written last. And then I'm going to add negative 3xy, and I'm going to look for other xy's. There's one right here. Negative 3xy plus negative 2xy is negative 5xy. And that's going to go right in front of the 17, because that's the next smallest term by degree. We've got an 8y squared. I don't see any other y squareds in this problem, so I'm just going to bring that down. I don't see any y to the thirds, so I'm going to bring that one down. And the question is, what goes next? Because we want to write the biggest exponent first. It looks like this is going to be written first in this problem. And that's going to be the degree, because this other term, which also has no like terms in this problem, only has a degree 3. Because when you add those two exponents together, you get 3. So this is your answer. There's really not many like terms in this problem. It is a quintic, because the biggest exponent, or sum of exponents, is 5. And there are 6 terms. So it's a quintic polynomial of 6 terms. Pause the video and try the 2 year turns. You'll notice one of those year turns is multiplication. So remember, when you multiply variables, you add the exponents. All right, here's the answer to number 3. Guys, it doesn't matter the order of the 2y squared and the 4x squared. Since those both have a degree of 2, you could invert that order and that'd be fine. But the x to the third term comes first, and the 3y would have to come last. And then here's the answer to number 4. At least that's the first part of the answer, so I multiplied 3x squared y times xy. So we add the exponents for the x's, and you add the exponents for the y's. And then I multiplied 3x squared y times negative 5x. I did the same thing with the exponents. Next, you should distribute the negative 2xy. So that's going to be negative 2x squared y squared. And negative 2xy times negative 5x is a positive 10x squared y. So remember, you don't have to have the exact same variable to multiply. And of course, anything times 1 is itself, so that doesn't change anything. And then finally, just add any like terms that you might have. Don't know that I see any like terms in this problem. Gotta have the exact same variable for the x and for the y, and I do not see that. So this should be my answer. It's already written from biggest degree to smallest degree. Degree is 5, because these exponents here added together is 5. So it is a quintic. And again, there are 6 terms, so it is a poly of 6 terms.